It's also Earth Science time. That's what we like to say. Earth Science time, and it's going to be, let's call this Igneous Activity. Igneous Activity. We had talked about igneous rocks a while ago. Isn't that right? You remember a little bit about igneous rocks, right?
Back in September.
Back in, I think it was September, yeah. Do you remember about igneous rocks, though? Do you remember some types of igneous rocks? You do. I think you do. You've heard of granite.
Oh.
Yeah, granite's an igneous rock. You've heard of, what's the other one that we've been talking about recently?
Calcium?
That's a mineral. Basalt. You remember about basalt? We had a little chart of igneous rocks, and what were the two things that determined how we classified an igneous rock? Do you remember? Go back in your notes real quick, because there were two, not two names of igneous rocks, but there were two ways that igneous rocks could be classified, or we always classify igneous rocks in two ways. Sorry, what? You're still thinking of minerals. Not, yes, but not specific enough.
Igneous rock as resources.
Yes, that's,
Classification.
okay, yeah, that's what we're looking for. Classification.
Extrusive, intrusive.
There we go. The first way we classify them is extrusive or intrusive, right? Let's write this down. So we're just going to review igneous rocks real quick. So we have extrusive versus intrusive on one, I don't know, axis of our table. What was the other way that we classify igneous rocks? Hannah, do you have it there?
I have their chemical composition.
Yeah, exactly, their composition. So we had whether they were, do you remember we had, from the highest silica content to the lowest, we called them granitic, which your book calls, and you should write this down too.
And basaltic.
Yeah, rhyolitic. Remember, granitic and rhyolitic go together. Your book calls it rhyolitic. I've always heard it called granitic. I'm sure either is fine. I would guess that since your book is newer than when I went to college, rhyolitic has become the common parlance, but people would know what you were talking about either way. Granitic or rhyolitic. The middle one was called andesitic, and then the last one, the darkest one, was called basaltic, as you said. And then these, as we said before, this is high silica over here, and then low silica over here. If it has low silica, what is it mostly made out of? Do you remember the other word? We called this felsic.
I know. And mafic.
And mafic is the other end, yes. Mafic. So we have these rocks classified by whether they're extrusive or intrusive, and whether they were granitic or basaltic or somewhere in between. How could we tell by looking at it whether a rock was extrusive or intrusive? This is going to be very important for today's lesson as well.
Crystal size?
There you go. Which was larger?
Okay, so if it's intrusive, it was in the earth, meaning it had more time to cool, so they would be bigger.
Bingo.
And extrusive.
Bingo. So intrusive igneous rocks, and write this down. You have it in your notes somewhere before, but write this down. Intrusive have larger crystals. They tend to have larger crystals because they took longer to cool. Large crystals. Why would they have taken longer to cool? It's magical inside planet Earth?
Though it's still hot.
Yeah, it's warm inside planet Earth, which is kind of like magic. You get a nice warm hot pocket, that's magical.
Not really.
No, yeah, it is actually. I think
Is that cup of coffee magical?
a little.
You can't have that
Why?
because it's not in a clear container.
I can do what I want. You're mistaken. Okay, extrusive igneous rocks then would have small because in general, it's cooler on Earth's surface than inside of Earth,
So they cool.
and so they cool faster, and so the crystals don't have as much time to grow. We did have names for each of these. That's not really what we're worried about now. If you are worried about it, blah, 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 you can go back in the notes or you can watch the video we talked about in that. But basically, we had two ways of classifying igneous rocks, and these are going to be very important for us again today. So I just want to review that with you real quick. We classify them on whether they're extrusive or intrusive, which we can see by their crystal size, and we classify them on their composition by felsic or mafic, which we can see by their what? Do you remember? What do we look at to see whether it's going to be granitic or basaltic? It's, no, that was this. Its crystals was,
I'm gonna say color.
yeah, color. The darker it is, the more mafic it is, almost always. And they have different shades of like purple and red and green in there too, but the darker it is, the more mafic it is in general. So I'm going to erase that real quick. That was just review.
That is
More like credit.
I'm gonna smear it around on my toast like butter. But now we're going to talk about, we have two kinds of igneous activity then, and we're going to talk about them in order. based on what we just said, what do you think the two kinds of igneous activity are? Well, if we had two different ways that igneous rocks can form.
Intrusive and extrusive.
There we go. We're going to have intrusive and extrusive. Let's start with extrusive, and then we're going to talk about intrusive later. We had just talked about before we started the video, there are two major features that form as a result of extrusive igneous activity. Real quick though, remind me, what would be like, if you were a third grader watching this video or in this class, what would be a way we could phrase to you what extrusive means?
Outside.
Yeah, it's on Earth's surface, right? That even, a third grader might be confused by that.
It's outside.
It's, if the Earth were like a little orange, it's on top of the rind, right, instead of inside the orange. I don't know.
Or
I don't
like
think-
exit, you're out, like you go out.
Oh, that's good, yeah. X here, like exit means outside, right? You're gonna exit the building, you're gonna go outside the building. If you exit this room, you're gonna go outside the room. So extrusive igneous rocks are those that form outside of Earth, right? On Earth's surface. And we had two major features, things that we could actually look at and go to and drive a bus on sometimes if it's safe. What were they? The two extrusive igneous features. Volcanoes and flood basalts. If you have the definition of a flood basalt in your notebook, that'll be sufficient for that. But basically a flood basalt, well, you can probably guess, what kind of rock is it going to be made out of? Very good, yes Levi, you're right, it is made out of basalt. And then why would it be called a flood basalt?
There's a flood of basalt.
Yeah, just like pouring over the surface, right? We could even probably consider this a type of volcanism. In fact, another word for extrusive activity in general is volcanism. Volcanism. And as I said before, before the video started, there is a real overlap between flood basalts and what we call shield volcanoes. Speaking of shield volcanoes, there are three types of volcanoes. Did you read about them? What are they?
Shield, composite, and
Put shield over
Cinder
here.
cone.
cinder cone, yeah.
Shield, I'm going to put composite over here. I'm going to put cinder cone in the middle. And cinder cone's kind of a, I don't know, we don't care about him as much generally.
Why?
He sucks. No, that's not true. He's nice. We just,
I bet he's crying now. Now you just created an eruption.
yeah, created an eruption.
You said cinder cones?
Cinder cone.
I
Here's
know.
what old people call the $64,000 question. Here's the $1 million question. What determines, like, it's just a random thing whether whether a volcano is going to be shield, composite, or
The
cinder cone?
magma?
There we go. The type of magma. Let's put this over here. Can you see it on the screen? Yep. Type of magma.
And whether it's explosive or not?
Yep. Determines. I should mention right. Determines quite a few things, right? It determines the volcano type, eruption type, and rock type, right? Like the resulting rock is going to be different depending on the type of magma.
Yeah, because isn't there blocks and stuff, like volcano blocks, but those only happen with explosive.
And when we say type of magma, are we talking about intrusive magma or extrusive magma? No, we're talking about,
Like silica?
yeah, it's the silica content. So we just call it what or what magma.
Oh,
High silica or low
no.
Yeah, but we have special words for those. You're right. Felsic or mafic. Good. So type of magma determines the volcano type, which we have here, the eruption type, which is basically what or what.
How it blows out the
Yeah, both.
Explosive or non-explosive?
Yeah, explosive, or you can use a gross word like ooze. Kind of gross. But basically, and you should write this down, the more silica content, the more felsic the magma, the more viscous it is.
More what?
More
The more
felsic
viscosity it has.
the magma, the more viscous it is. And this results in a lot of, I think, cool things. So the higher the silica content, the more viscous. When I say more viscous, because there's sometimes some confusion about this, what does more viscous mean? What would be more
higher
viscous?
viscosity.
Yes, higher viscosity.
It can flow easy.
No, and people think that. But high viscosity means, remember, viscosity is the resistance
Oh,
to flow.
yes, so then it flows.
So high viscosity is thick.
Okay, I have a question.
Peanut butter, give me a second. Peanut butter has a high viscosity, water has a relatively low viscosity. Peanut butter has a higher viscosity than water. It flows more difficultly. I don't know, that's a bad way to phrase it. It has more resistance to flow, yes.
Is it the higher the temperature, the less the viscosity? So like, the hotter it is, it's easier for it to flow?
Yeah, in general, for liquids in general, that's
Okay.
true. I think there's a video of me telling the physical science kids about this when we talked about viscosity, but one way, have you ever heard of cooking?
No.
Okay, let's try a different example then. No, if you've ever cooked, like if you've ever tried to put some oil in a pan to saute something, we've talked about sauteing before in this class, but if you ever sauteed something, a good way to know when your oil is hot enough,
It should take water.
you can do that. You can take a little bit of water and it goes, right? That's nice. That's a satisfying way to do it. But another way, an easier way, is that because the viscosity of oil in any liquid gets lower, the hotter it gets. If you just heat your oil up until it's about as runny as water, right? When you put the oil in it first, when it's cold, it's going to be like, right, high viscosity. But then the hotter it gets, the runnier it gets, the less viscous it gets. And so if you heat your oil up until it's about as viscous as water, that's hot enough to cook your little pancakes in or whatever, your corn doggy.
Why do you cook your pancakes?
Because otherwise they're raw. What do you mean, why do I cook my pancakes?
Pancakes?
You're gonna put like,
And you're
Like
not
pancake
gonna
batter.
fry your pancake.
You put oil on when you make pancakes.
I use like Pam.
Yeah, that's oil. That's oil.
I thought you were talking about like olive oil. And you just
Like a
put it
thick
in.
coat, like you
You
fry
could- no, I usually
chicken
use
in.
butter.
I was like,
Usually use butter. I wish this
That's
was
what
a
I
cooking
was
class.
thinking.
I wish it was cooking class, but it ain't.
Yeah.
But
yeah.
the more felsic the magma is, the more viscous it is. So the thicker the magma is, the more silica there is in there. And then because of this, it makes felsic. This one, so the composite volcano forms from felsic magma. And it's usually associated with what eruption type then?
Explosive.
Explosive eruption type. Because since the magma has such a high viscosity,
The gases.
the gases get trapped and it all comes out in one big bubble, right? It's kind of like if you imagine, this would be a fun lab to do, but we're not going to, but if you imagine heating water with a low viscosity on a little plate, hot plate, and peanut butter with a high viscosity, they would both bubble, but the peanut butter would be big bubbles fairly infrequently, where the water would be small bubbles quite often. Do you see what I mean? Because of the viscosity. Yes.
What is blow up?
This is supposed to be the word explosive.
Okay.
Let me try again.
It looks like it exploded.
Okay, the problem is that the little marker has a dead spot right there where I want to use it. Explosive. It's not much better, but it's a little better. We're going to talk about Cinder Cone last, but the shield volcano then, as a converse to that, is what? Probably mafic magma, which remind me is, how's its viscosity?
It's very flowy.
Yeah, flowy. So we can call this a flowing, that's a better word than oozy. Flowing eruption. I should put the word eruption after this. Explosive is an adjective. We're going to put eruption after to make it a complete thought. So composite volcanoes are made primarily of felsic or granitic, though we sometimes call it granitic magma, that explode. Which one of these do you want to live next to?
Impossible.
The correct answer is neither one, but if you had to, right, if you got a summer house and a winter house, you want them both to be not, you just don't want to live here because you're going to blow up. That's bad.
Because we don't know about cylinder cone.
You're right, we don't know about Cinder Cone yet, so maybe that would be the best
But
recipe.
you said those.
No, I did not say that. I was going to say that. I said that, I don't remember what I said, as usual.
You said we're gonna put them in milk because he sucks.
So Cinder Cones are slightly different. They're usually made of like, well, I'm going to just draw it down here. Cinder Cones are made of, like, I don't know, it's almost like leftovers. Like it's the piles of magma that are left over, usually from a composite eruption. So what we call tephra, which is one of your vocab words, I think. What's tephra? Okay, so tephra, which is like erupted material, chunks of, usually blocks of magma that have solidified, but tephra from explosive eruptions. Let me read you what the book says about these. When eruptions eject small pieces of magma into the air, cinder cones form as this material, called tephra, falls back to earth and piles up around the vent. Cinder cones have steep sides and are generally small. Most are less than 500 meters high. The Lassen volcanic park cinder cone, shown in figure 18.1 is 700 meters high. It's just, let's draw a little picture of each of these. Composite, what's it going to look like? And why is it called composite, by the way? Yeah, there's layers of kind of magma from the sort of followed by a layer of tephra from when it fell back down to earth, right? So when it first erupts, the magma comes out, forms a little mountain, and then as the stuff that was exploded out falls back down, that forms another little layer of tephra. Same thing, as we go up, it's going to be alternating layers of those, because each eruption adds a new little layer on top, right? And then this thing in the middle, people always draw it in the middle, but what's that thing called? It's a vent. We're going to call that the vent. And then what's down here? Magma chamber. That's going to be true for all of these. How would the shield volcano look then, relative to the composite volcano?
It goes like this.
Yeah,
it has a big diameter and a small.
Much wider. Big old base, but it's not very high, right? It's usually not very high off the ground. So here's the magma chamber. The largest volcano in the solar system. Do you know it?
What?
Isn't it on Mars?
It is on Mars. It's called Olympus Mons, and it's a shield volcano. It takes up maybe a third of one of the hemispheres. It's a huge by area volcano. It's also the highest. But something interesting about it, since it's a shield volcano, even though it's the largest and highest mountain in the solar system, that might not be true, the largest and highest volcano in the solar system, if you were to climb to the top of it, you'd be on Mars for one thing, so you'd have to have like air tank and some other stuff. But you climb to the top of it, you wouldn't even ever know that you were going uphill, right? It's so large in its base that you would never feel the uphill climb. You see what I'm saying? So even though it's literally the highest volcano in the solar system, you would never feel like you were walking uphill because it's so shallow. Does that make sense?
Yeah.
If you've ever seen a picture of Mars, you can really see this volcano from it. It's really cool. But it's a shield volcano, probably formed from what kind of magma?
Non-explosive.
Yeah, specifically basaltic or mafic magma. And then the cinder cones may just have it's kind of like the second layer of a composite volcano. It's just a little tiny pile of tephra coming out of a vent. I drew it little tiny. That's still the vent. This is still tephra. There's still not always, usually this is connected to a magma chamber from some other, an associated composite volcano. We got the extrusive side filled up pretty well. Let's talk about intrusive. Oh, do make sure you know the vocab word for pyroclastic flow. Pyroclastic flow is just like the cloud of ash and gas and dust that comes off of an explosive eruption. That's the most dangerous part of explosive eruptions, is not that you might get a boulder on your head or your car or your dog, but that would be sad. But the most dangerous part for most everyone is the 1,000-degree cloud of toxic gas coming down the volcano at you. You guys know about Pompeii? We watched a video about Pompeii in 8th grade. Do you remember that?
Yeah.
Are you familiar with Pompeii, though? The volcano that
So sad.
erupted, or Vesuvius was the name of the volcano that erupted and wiped out the town of Pompeii.
Kind of like the song though.
Oh yeah, that song. That's a good song.
It's a good song.
That's a good song. We should have that be the theme song of the class, because it does talk about, one of the lines is about the pyroclastic flow. It said, what does it say? Something about clouds of ash. I can't remember.
I think we should listen to it.
We will, but after the video's done, because YouTube might take the video down if I put a copyrighted song in it. I worry about things like that. Anyway, so.
Do you have a pause button?
Yeah, but we're not going to do it right now. We'll talk about it later. Intrusive igneous activity is that which takes place where then? Inside of Earth, right? Intrusive, inside. Extrusive, exit. That's how I would tell this to second graders. You're not second graders. Intrusive, now be careful, because try to say in the mantle. It doesn't have to be in the mantle. It's, in fact, usually we encounter these things in the lithosphere, so it can be in the lithospheric mantle. But this is generally in the crust. It's inside the crust, though. Now, it doesn't have to be all the way inside of Earth in the mantle, but it does have to be inside the crust. All of the features that we talk about for intrusive activity are what? You remember the word that we used? The vocab word? Plutons. What do you think this word might be related to and that you know from before? No. Good guess. Pluto, which is a planet.
No, it's not.
You're right. Whew. It's a dwarf planet. But Pluto, that dwarf planet is named after what?
The archaeology
No.
back in the day.
No, do you guys not know?
Tunes.
Wasn't he an old dude from
Music.
It's a Greek, no, it's a Roman mythological character who was the god of the underworld in Roman mythology, Pluto. It's the Roman correspondent to the Greek god Hades. This is named after hell.
Nice.
Pluto is the Greek or the Roman god of hell, just as Hades would have been the Greek god of hell. These are named after because hell is underground.
Yeah.
Pluto, that's why these are called Plutons. There are some, these are the ones we're going to talk about. I'm going to make sure I get all of them. I think there are 5. We're going to combine 2 of them, though, just like your book does. Boop, 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 boop. 4. Batholith. What did he say? Batholith. Batholith. We had another word in our Earth Science year that had the prefix batha. Yeah, bathypelagic, which, if you remember, meant deep, deep. Bathios is the Greek word or Greek adjective for deep. And then lith, can you remember what lith means? Like lithification or lithosphere, those all mean what? What's the lith part mean? What? No, it means rock. Lithium has the same word. It means stone or rock. So this is a deep rock. A lot of these things that are really cool science names, I'm trying to tell you this my whole life. A lot of these things that are really cool science sounding names are really just like kind of dumb sounding names that are translated into Latin or Greek so that they sound cooler. So batholith, fairly cool word, but it just means deep rock, right? It's a rock that's underground. In fact, it's usually a great big rock that's underground. The definition of batholith, you have all these definitions, so we're going to talk briefly about them. But batholiths are enormous, right? They cover thousands and thousands of cubic miles or cubic kilometers, right? They're enormous. They cover entire regions. You know about the Black Hills?
Yeah.
That whole mountain range, I'm pointing towards the Black Hills, that whole mountain range is a batholith that has been risen up, that has been uplifted from underground, so it's on the surface now. But that whole area, from like basically from, it's intrusive, but it has been uplifted.
Did you know it talks about
Thank you for the question. Listen to what Levi said. We don't consider things extrusive after they've been uplifted. It's still an intrusive feature. It's still a batholith. It's just been uplifted, so it's on the surface. But that, if you think about, I call it Maverick Junction. It's that little place outside of Hot Springs where you can go to the gas station and stop for a second, but it's not in Hot Springs. That's about the southern limit of the Black Hills. Clear up to like Spearfish. That whole area, you think about how long it takes if you've ever driven to Spearfish, you've probably taken that exact route. But that whole area is one batholith, right? It's just been uplifted. It covers hundreds of square miles, it's thousands of square or cubic kilometers in volume. The next one is called a Lacolith. This little prefix here means lens. And where the batholith is like a great big old thing, this is a batholith. The Lacolith is usually smaller and it's specifically lens shaped or like eyeball slit shaped. Just because I'm drawing this one above this one, that doesn't mean that one has to be higher than the other. It's just where I have room to draw.
So this one has a big chamber.
Yeah, it's still a large chamber, but it specifically has to be lens shaped. Usually because it's forming between 2 layers of some other kind of rock, and it kind of pushes them apart. Like if you think about, I'm trying to think of what kind this would apply in your life. Like if you had 2 sheets of, this usually happens. You have 2 sheets of paper and you squeeze some toothpaste between them. You know how you're always doing that? No, but you can imagine that happening, right? You have your 2 sheets of paper that are lying flat, and if you squeeze toothpaste between them, it's going to like make a little blurb, right? A little lens-shaped bubble. It's the same exact thing, right? There's 2 layers of rock, and some magma seeps in, and it fills up, and it becomes lens-shaped.
You said glue.
Oh yeah, you're right, glue. When you squirt some glue in between 2 pieces of paper, that's the right way to do it. Sill and dike are similar. They're both small, except a sill is parallel to the surface, and a dike is perpendicular to the surface.
That's a weird question.
There's some really cool pictures in your book of this. And in fact, if we go on our field trip, I'm going to stop us at a dike that's in the Black Hills that's made of the mineral, or the rock pegmatite, which is really cool because if you remember, pegmatite has enormous crystals that probably took hundreds of thousands or millions of years to cool, but it has enormous crystals. You can see like gemstone quality tourmaline, like a big thing as big as your finger, gemstone just sitting there by the road, and it's really neat. People just drive by it all the time and throw their french fries on it, but it is really cool. We're going to stop there if we get a chance on our field trip. But a dike is perpendicular, it's scooching.
At 8:40.
Anyway, we're done, so bye.